was called the world's first pregnant man, and today he gave birth.
But the court has gone the whole way, said there is an absolute constitutional right to same-sex marriage.
Hurricane Harvey is pelting the Texas coastline.
There is an increasing attack on freedom of religion, speech, and conscience.
Welcome to the Issachar Hour, examining law, policy, and culture through the lens of the Judeo-Christian worldview to help you understand the times and know what you ought to do.
Well, good day, good morning, good evening, whatever part of the world you are. Welcome to the Issachar Hour. My name is Wayne West, and this is my wife, Doreen. What are we doing today?
Well, good day to those listeners on the Issachar Hour. Today, in this hot summer day, we'll be talking about keeping your cool on climate change.
Keeping your cool on
Climate change is a very emotive topic, very relevant to us in this sweltering summer that we have been having.
Yeah.
So we'll be talking about climate change, the science of it, the politics of it, the ideology behind it, all the aspects of it, and we'll be trying to keep our cool on climate change, on the matter of climate change.
Yeah, and trying to help you to keep your cool on the matter of climate change as well. So the issue is, what is climate change? What are we discussing when we say climate change? I think it started some years ago as global warming. People used to say there was a global warming, and then they phased that out and it became that there is climate change. So there are some real issues here.
Why was it phased out? Why was it changed from global warming
into climate change? Because I think it was it may have been becoming a little bit difficult to be sure that there was global warming. But you could more appeal to climate change because climate change refers to the average weather condition over a period of time. So people could say, look, the weather will change or is changing over a period of time, but on any given day, it may not be as hot as you think it would be if you were having global warming. So it would be easier to appeal to climate change as a statistical change in the weather condition over a long period of time than to say, look, today you're going to have a very hot day, tomorrow you're going to have a very hot day, and so on. So I think that's one of the reasons why there was this shift over. It was a little more challenging to demonstrate the global warming. So what are we dealing with here now? The Earth is a system. We live in the Earth, and it is a marvelous system. We ourselves, our bodies, the animals that live on the planet, etc., are marvelously designed, marvelous anatomy, marvelous physiology. Anatomy is structure. Physiology is how we function. And we need to have an environment that will allow for our survival. And that environment includes the temperature at which the external environment is. So there are a number of things that influence the temperature of the external environment. And one of the things that does that is what's called the greenhouse effect. And there are certain gases in the atmosphere that are referred to as greenhouse gases. And the concentration of those gases can impact the temperature and the climate. So it has been one of the significant gases is carbon dioxide. Carbon dioxide produces what's known as the greenhouse effect. And we're going to look at the greenhouse effect in time, but we just want to share with you that carbon dioxide is not the only gas that produces a greenhouse effect. Water vapor also does. And the other things like methane,
nitrous
oxide, things like what we use to cool our fridges or cool our air conditioners.
Those wouldn't be gases, those would produce the gases, but the greenhouse gases themselves include carbon dioxide, nitrous oxide, water vapor itself, and methane. Those are the greenhouse gases. But the effects that produce these gases vary a lot. Aerosols and so on.
So carbon dioxide came into focus because people have been measuring carbon dioxide levels in the atmosphere either directly nowadays or indirectly using samples from from ice and so on, or what obtained over millions of years. Now, it has been found that today, the carbon dioxide level, and carbon dioxide again is a greenhouse gas. The carbon dioxide level is about 418 parts per million. So if you take a million as the whole, 1 million parts is the whole, in the atmosphere, carbon dioxide accounts for 418 parts per million. Okay? And
this is high.
This is high because measurements over the last 6,000 years or so show that carbon dioxide was about 200 and something. So it moved from about 200 and something over the last 600 years up, leading up to the 1800s. For the last 6,000 years up to the 1800s, carbon dioxide levels were about 200 and a little bit, 213
so
or
what
so
is the
parts per
normal?
million.
Is there a defined normal carbon dioxide levels? And who knows what it is?
I don't think you can define a normal. What you can say is that at particular levels there are effects. Okay? So it was found that from the 1800s backwards 6,000 years or so, it was about 200 and something parts per million. But it started rising after we came to what we call the Industrial Revolution, when people started using fossil fuel, which is oil, and so to provide energy to do things like manufacturing or to cool and so on and so forth.
Transport.
And that sort of thing. So once you started using fossil fuel, it is found that the carbon dioxide levels started to rise from 200 odd to 418 as of, let's say, 2021, 2022. So there's a projection that if this continues, carbon dioxide will increase.
Yes, but carbon dioxide levels, this is not the first age in which carbon dioxide levels have been high.
No.
The Industrial Revolution is not the first time in the history of mankind when we have had high levels. We've had high levels at other times. So this must also be taken into consideration.
So in other words, you would say, if you would approach it from a scientific point of view, that the activities of human beings in terms of the Industrial Revolution,
neither necessary nor sufficient.
It's neither necessary nor sufficient. It is not necessary because we've had higher carbon dioxide levels in the past. In fact, during the time of the dinosaurs, which is about 65 million years ago, it is said that carbon dioxide levels were about 2,000 to 4,000 parts per million.
Well, first of all, that is something that that's a kind of an assumption. It's not something that they actually can measure. It's kind of using ice and all of those things. I
wouldn't say it's an assumption.
It's an approximation.
It's an indirect measurement.
It's an indirect measurement.
Yeah, it's an indirect. I just think from today where you could go outside and...
So it's an indirect measurement for one. But two, if that indirect measurement is to be believed, then it would seem that when there were not so many humans and not all that industrial activity around, carbon dioxide levels were higher. So the presence of
about 5 times higher, as much as 5 or 10 times higher.
So this is the first point we must make. The presence of human activity is neither necessary, it would seem, nor sufficient to cause these high carbon dioxide levels.
Because also they said, it is said, so that was the time of the dinosaurs. Right. And they said the Earth at that time was much cooler because of the
So the presence of high levels of carbon dioxide is neither necessary nor sufficient to cause...
No, the presence of human activity.
I'm saying the carbon dioxide levels were high when the Earth was cooler.
Well, it wasn't. No, it wasn't cooler. They said that during the time of the dinosaurs, the Earth was warmer, and not only
the Earth was warmer and the carbon dioxide levels were higher. But is that cause and effect? Is what I'm saying.
Well, that's another consideration because let's put it this way.
Is that cause and effect? Can we say it was warmer because the levels were higher?
It is. I think it is assumed because the other considerations for warming, and you see, this is where we
and you have to know what is cause and what is effect as well.
Right. What you can see, what can be said.
Two things existed together.
They
can say that they are cause and effect.
And that is really to be determined.
That is to be determined.
That is really. Is it cause and effect? It's to be determined. But certainly at that time, the sea levels were higher. The Antarctica, I gather, was a tropical kind of temperature, so Antarctica, instead of being covered over with ice, which is the South Pole, was actually a tropical place where living ordinary
and then it got frozen.
organism, and then it got frozen. The other time when carbon dioxide levels were high, and high meaning almost like 400 around we have this time, was during what's called the Pliocene period, which is about 3 to 4 million years ago. So again, you had high levels, and at that time it said the Earth was also warmer. So there is this association, and it's an expected association, but can we correlate it and say to the extent and all this sort of thing we will develop?
Well, we need to say, what do we know as a fact?
Yeah.
What do we know as a fact? What are the facts? We can say that carbon dioxide levels were much higher years and millennia ago during the time of the dinosaurs than they are today.
That's right. When there were no humans on the face of the earth.
Humans were not there.
So it could be argued that in preparing and discussing for carbon dioxide elevation, you should also factor in that human beings may experience elevated carbon dioxide levels even if we cease all our emissions from ourselves.
Because there were certainly no emissions back then.
That's right.
But this is methane from the dinosaurs.
Well, then they attributed some of the volcanic activity and so on. But the dinosaurs were big, so maybe they
produce a lot of methane. It's possible. But anyway, we need to keep a sense of balance, because we certainly must try to say, what if two things exist together, it doesn't mean that they are cause and effect. Not necessarily. And it also doesn't mean two things exist together that it is necessary or sufficient for one of them to be there to cause the other.
That is true.
We have to set that framework.
But why is it, as from a Christian point of view, it's important to understand what the discussion is on climate change? One of the reasons is that there's a lot of politics overlying the data, the raw data. And there are persons who have particular ideological positions. For example, there are persons who wish to use crises to control what the world population does.
Yeah, we know this.
So that they can say, you must do this, you must do that. And there are persons who seize on crises to do just that. So
and the way they do that is to spread panic.
It's to spread panic. So, and some of these people, for example, are fairly hostile to human beings in that they don't really like human beings a lot. The image of God is not one of their priorities. And in fact, they
feel that there are too many human beings on the earth anyway, and we need to reduce the numbers.
They want to depopulate the earth.
They want to depopulate the earth.
So they would seize on something like this.
Yeah, to spread fear and to promote their agenda of depopulation. On the other side, though, although I have a healthy dose of suspicion of these persons with this agenda, I must say that God gave man the earth to take care of it.
Absolutely.
And certainly it's our duty to care for the earth that He has given us.
For the whole creation.
For the whole creation. And so we must also hold it as a sacred duty to not just live on it and use it and do anything we want on it. Yeah. But we have a sacred duty, because it was given by God as our responsibility to care for His creation.
Absolutely.
And that must be taken very seriously as well.
Absolutely. So it is within the Genesis account and within the Bible an understanding that we human beings have to take care
of God's creation. That's why He put us here.
And logically, we need that creation to survive. So if we don't take care of it, we will not.
There's self-interest.
There's self-interest,
So there's a divine duty and there's self-interest. To care for the creation.
That's right. But
we don't want to minimize that.
We don't want to minimize that. But we must also appreciate that there are persons and groups who, like I say, will use those things.
Use crises and create crises.
To put systems in place to control everybody, to say what everybody can do, including to depopulate the earth.
Absolutely.
Because like I say, they don't like it. And there are also people who some people refer to them in a disparaging way. I don't know if it's as tree huggers. There are these persons who...
I used to do that once, but I'm not doing it anymore because... you can cut both ways, this kind of labeling of people. And not everybody who is very concerned about the environment can be called a tree hugger. Some people are just very concerned about it. And, just like in any other ideological issue, there are those who genuinely think they're doing a good thing. And then there are those who use what is happening to get their own ends. And so I would not call people that, just like some people would call other people climate change deniers. And so I would avoid those labels. I would say we need to look behind the issues and see all the factors that are...
and as you introduce the term climate change denial, the fact is the people who are pushing this, the political agenda, use a strategy of labeling
just like
and
anti-vaxxers.
ostracizing in order to prevent people examining what actually
what
is.
they say.
So in other words, instead of examining the science and critiquing the science, because the science gives you the data, what you do with the data depends on your worldview. But instead of
anybody who questions it is attacked and call the name.
That's right. So, and we see that in a lot of different ways. You see it in terms like the trans debate, or the LGBT debate. If you don't go along with the narrative, you are ostracized and called name and anti-scientific and so on.
It's a common tool of today's
strategy. Right. So and this is the left-wing Marxist people.
This is why I don't like to do it. I don't like to use it.
So what we're doing today is, because we are aware that there are a number of factors involved in climate change. There is the raw scientific data, and then there are different worldviews from different sets of people.
And different ways of interpreting the data.
That's right. And there is a strategy to intimidate you if you don't go along with it, and to prevent you from looking at the data, but because of the intimidation. So we are hoping to see if we can help you to understand what this is all about. And as Christians, it's important that we do not allow people to control what we do and to take away our freedoms in order to achieve ends that are ungodly. So the first thing we're going to do then, we're going to look at greenhouse gases. Greenhouse gases.
What are they? What do they do?
And what do they do?
Why are they important?
So let's take a look and see if you can follow along. Greenhouse gases. All right.
In this video, we're going to talk about the greenhouse effect and also the greenhouse gases which cause the greenhouse effect. Now let's just start with a basic idea. Imagine if Earth had no atmosphere. What would happen? Well, you have the sun, which is on average 93 million miles away. It's sending electromagnetic radiation our way to the surface of the Earth. We're actually getting a very, very small fraction of the total electromagnetic radiation of the sun. And then that would heat up the surface of the Earth. Now, what I have always found mind-blowing is anything with temperature will emit electromagnetic radiation. And so it's emitting some of that energy. It's losing some of that energy to electromagnetic radiation. So the surface would be releasing that, and it would go out into space. But now let's introduce the idea of an atmosphere. And in particular, we're going to think about our lower atmosphere, which starts at the surface and goes up to about 5 to 9 miles in altitude, often known as the troposphere. Now, the troposphere has molecules in it, has gases in it, like carbon dioxide, like water vapor, like methane. Others include nitrous oxide and chlorofluorocarbons. You don't have to know the chemical formula of all of these things. But what's interesting about these gases that are in the lower atmosphere is that they can absorb some of those electromagnetic waves that the surface of the Earth is emitting. So some of that energy will make it out to space, but some of that energy will then be absorbed by these molecules, by these gases, and then they will emit some of that back to Earth. And so that's why it's called a greenhouse effect, because of all of that energy that might have been sent out to space if you didn't have an atmosphere. Not all of it is. Some of it is reabsorbed by the atmosphere, which then sends it back down to the surface, and that process can go on and on and on. You can imagine that it's trapping some of the energy. Now, the greenhouse effect and greenhouse gases, the ones that I just listed, they're oftentimes associated with man-made climate change and global warming. And they are for good reason, but it's important to realize that we actually need some base level greenhouse effect just for Earth to be habitable in the way that it is. Without greenhouse gases, Earth's surface would be about negative 18 degrees Celsius, which is the same as 0 degrees Fahrenheit, which I think most of y'all would recognize is very, very, very cold relative to what the actual averages are, which are 15 degrees Celsius or 59 degrees Fahrenheit. And of course, these are average temperatures, but 59 is a nice, refreshing, brisk day, not a frigid day like 0 degrees Fahrenheit. And of course, these are averages. It fluctuates around this depending on time of year and where you are. But this makes it clear that we do need these greenhouse gases to keep the Earth reasonably warm. Now, the problem is if the concentration of these greenhouse gases go out of equilibrium, become unusually high. And it does look like that is indeed happening. This right over here is a chart, and the way that we're able to figure that out is by taking ice samples and rock samples and looking into our past through the geologic record of how much carbon dioxide there has been over the last 800,000 years. And 800,000 years is a very long time period. Modern human beings have only been around for 200,000 or 300,000 years. And what you can see is the concentration of carbon dioxide has roughly fluctuated between about 200 parts per million and about 300 parts per million, at least over the duration of this chart. But in recent times, we've gone well beyond that. We've almost gone double that average right over here. And this is actually the highest levels we've seen in 3 million years. Now, it's important to realize that carbon dioxide makes up a small percentage of our atmosphere. In fact, all of these greenhouse gases make up a small percentage. 78% of the troposphere is nitrogen. 21% is oxygen. The last 1% is things like argon, water vapor, carbon dioxide, methane. So even this small amount, when the concentration increases dramatically, can have a huge effect. Now, you might say, hey, we were at these levels 3 million years ago, roughly. Maybe this is just some type of cycle that we're seeing on Earth. And to recognize that this is indeed man-made, we just have to look at a chart like this. This tells us two things. This tells us annual emissions in this blue line, this blue curve, and then the total emission or the total concentration in the atmosphere. Because one of the things about a greenhouse gas like carbon dioxide, when it's emitted, it doesn't just disappear. And we can see if we go to the pre-industrial revolution or the early stages of the industrial revolution, CO2 emissions were pretty low, pretty close to zero, at least on this scale right over here. There might have been some basic CO2 emissions. People had fires and stoves and things like that. But then as the Industrial Revolution came into play and we started using fossil fuels more and more to fuel transportation and factories and other things, our emissions have gone up dramatically. And this coincides with the total concentration going well above that 800,000 year average. So it's important to keep in mind the greenhouse effect is needed to some degree, but the problem is when the concentration of greenhouse gases like carbon dioxide go well beyond their historic averages, which can over time warm the Earth, and even a few degrees centigrade of warming the Earth can have huge consequences on our environment and on our weather. I'll throw out one last idea just for kicks, because even though it's called the greenhouse effect, it's actually not how actual greenhouses work. The greenhouse effect, as we just described it, is really based on this idea that things are getting the infrared radiation, the electromagnetic radiation is getting reabsorbed, which then gets re-emitted back to the surface and vice versa. In a real greenhouse, you can imagine that it is made out of glass. What's happening is the sunlight can come in and it's warming the surface and it's warming the air inside the greenhouse, and then that air is not allowed to circulate. So if the greenhouse had a little hole at the top right over here, that hot air would be allowed to go out and circulate with the cool air up here. But the air isn't allowed to mix, and so the air gets hotter and hotter and hotter. It actually turns out that the glass can let the electromagnetic radiation out, unlike greenhouse gases. So it is a different actual physical process, but you can see where people try to create the metaphor.
Right, so the greenhouse effect really is a way of trapping energy, of keeping heat
on the surface
of the earth and in the atmosphere. And we need that. We living organisms need that. We cannot survive if the temperature drop to minus, say, 300 degrees or whatever it is. So we need to have some greenhouse effect, as the video showed. But we don't want too much, because too much of a good thing is bad, because it can raise the temperature. So it brings us to the point now that we are aware, because I think it cannot be denied that the carbon dioxide levels have been increasing since the 1800s. Mm-hmm. What we want to determine is, can we produce cause and effect? And to determine what kind of models, how do scientists go about evaluating the effect that changes in carbon dioxide levels will have on the climate, when you consider that there are a number of other factors that influence climate, influence temperature.
The first thing we want to ask is it safe to assume that the carbon dioxide levels that we now have are due solely or mainly to human activity?
Well,
but that's an assumption that is being made in all of this discussion.
Yes.
So we must say that the assumption, we know carbon dioxide levels are higher, that can be measured. And there is an assumption. And many people assume that, many scientists, climate scientists assume that this either primarily or solely it's due to current human activity. Now, there are several things that affect the production of these greenhouse gases. Like we said, there's volcanic activity as well. There's solar activity as well. There's the amount of cloud cover,
as we'll see.
and so on.
So
there are several things, and not all of them are human activity. But the ones that can be controlled maybe are human activity. Because there are certain things not due to human activity that also affect.
So the question is, because we're dealing with a complex system, meaning that there are a number of components. First of all, like you said, there are a number of greenhouse gases. There are other factors that influence the greenhouse gas effect, like the volcanic natural activity. Scientists have to come up with models, as they say, and use computers. So the model, they will make certain assumptions, etc.
They'll put in some data.
And they'll put in data and let the computer will make predictions.
And that's called a model.
So the first question we need to answer first is it sufficiently, has it been sufficiently demonstrated that the reason for the increase in carbon dioxide levels since the 1800s is due primarily to human activity? Some models say yes.
Most
models probably say yes. What effect do these things have? Does this increase in carbon dioxide level have? And this is where we're going to introduce it to models, the models for making computer models, and where issues arise with the models, because remember, important decisions are being made based on those models. And so if your models are incorrect, those important decisions, which can have far-reaching effects, would be based on a wrong consideration. So let us look at
what are computer models. What are they?
And you remember who did this particular
This
video?
was done by a group called Pacific Institute for Climate Solutions.
Right.
Pacific Institute for Climate Solutions. They did this brief video about computer models. Climate models used, which are computer programs, very, very complex programs, used to predict statistically what change will occur in climate.
Okay, so let's take a look at that.
Climate scientists are gaining an understanding of the past and are projecting what the future climate might be like through the use of climate models. But what are climate models and how do they work? Join us for the next few minutes to learn about these sophisticated tools and their application in helping us understand the recent past history of the climate. A climate model is like a virtual Earth. It's designed to mimic the real world so that scientists can project future climate scenarios. Climate models are composed of computerized representations of components that represent the atmosphere, ocean, sea ice, land surface, and other processes. Climate models do not rely on guesswork. They describe the climate system with mathematical equations based on laws of physics and solved with sophisticated computers. To give you an idea, what is shown here is the system of equations that describes the basic properties of the atmosphere, its temperature, density, velocity of the air, and so on. This is actually a relatively simple example that nevertheless can only be solved through the use of sophisticated computers. To represent the behavior and effects of clouds, as well as the movement of the air, its temperature, density, and moisture content, the basic atmospheric properties are evaluated at a grid work of points laid over the surface of the Earth that extends vertically into the atmosphere. The tower in the diagram gives an indication of what the grid looks like. We can solve the system of equations for these properties at every one of these grid points. This involves millions and millions of calculations. Because of computing and other limitations, some processes in climate models, such as those representing clouds, are described only approximately, using representations called parameterizations. These parameterizations are an important source of uncertainty in climate simulations.
So, what
just
did we say
basically
about
explaining
the
what a climate model is. And basically, it's a very, and makes a point, I mean, you need to remember this for later. It's a highly complex, highly sophisticated computer modeling.
Precise.
Right? Very precise.
Very precise.
Precise,
absolutely
complex,
100% precise.
Precise, complex, and sophisticated. You saw the formulae, the figures on the formula.
Well, they seek to make it as precise as possible in making predictions.
They seek to make it its precision and its complexity as impressive as possible by showing all these formulas on the screen.
But were there any uncertainties? Because I think that's where the issue is. The issue is we're trying to determine if the models that are being developed and using to predict, because remember, we are making some very important decisions about that will affect the economics of countries. And so you want to know that your models are as precise as possible, and not only as precise as possible, but that as far as possible, there really are no uncertainties, but that what they say will in fact come to pass. And did they say that you can actually achieve that? Well,
they talked about creating this grid with millions and millions of what are called cells, right? Yeah. And in each cell, which covers a part of the Earth and the atmosphere, is a cell, right? Going up several, quite a height above the Earth. So it takes in the atmosphere as well as the Earth. They create these cells, this grid, and into this, they fit in parameters like temperature, air movement, air moisture, and so on. And then the sophisticated computer formula, they will use these factors to predict statistically what the climate will be for a long time to come, and that's climate change.
Yeah, but I think
but to get to your point, I think he did say there that we must distinguish between climate change and weather.
We should. Weather, of course, is what obtains today
tomorrow,
and here and now.
Different from
climate change is what obtains over a long period of time. But I think he also made the point
that he said that there are some things in these very sophisticated and complex computer models. There are some things that cannot be accurately predicted. Some factors that cannot be accurately predicted. And so one of these, for example, and someone else that we'll hear today makes reference to this too. You cannot predict how much cloud cover you'll have at a certain time in the future. You cannot predict how thick that cloud cover will be. And so the speaker did refer to this, the cloud formation, the cloud cover, as one of the uncertainties of the climate model.
Right. So just want to recap, because this may be a little technical.
It's not perfect.
It is a fact that carbon dioxide levels have been going up since about the 1800s. It is also a fact that higher levels of carbon dioxide are associated from in the past with dinosaurs 65 million years ago and the Pliocene period 3 to 4 million years ago with a warmer climate. Those are facts. The question is, what is the nature of the correlation between the carbon dioxide levels and the temperature and the warmth of the temperature? And can we predict those things using models that have been developed by scientists? And I think that this video acknowledges that whilst the scientific models can be quite sophisticated and useful and good, they are not perfect. They are not perfect. There are uncertainties, right? So he continues. Let's go take a look at it.
He's going to talk now about what are the influences now. What are the external influences on climate change? What are the things, the factors that feed into it? So we talked about how they predict it, which is the modeling. Now we're going to talk about the factors that go into climate change. Produce it, yes.
So let's take a look at this. This is another part of the same video.
Pacific Institute, yes.
A number of climate research groups have the capability to develop and run the complex, comprehensive models that are required to understand the past and future evolution of the climate. The projections they generate help inform the world's policymakers about human-induced changes in climate. Their results have been impressive. The objective of climate modeling is fundamentally different from that of weather forecasting. Climate modeling deals with climate. while weather forecasting deals with weather. Weather and climate are different. What we all know and often complain about is that weather is always changing, sometimes on an hourly basis. Climate is a statistical description of the state and variability of a system. Weather forecasting seeks to forecast the weather for a short period ahead, while climate modeling seeks to project the statistics of weather for long periods of time, often for periods long in the future. A climate model can tell you it will be cold in winter, but it can't tell you what the temperature will be on a specific day. That's weather forecasting. Let's step inside a climate model to experience a simulation of the seasonal evolution of surface temperature. We are looking at the average temperature for each month as simulated for a recent 20-year period. At high latitudes, cool temperatures indicated by shades of blue occur in wintertime. Warm temperatures, indicated by shades of red, occur in summertime at high latitudes. You have to remember that what the climate model is showing are average temperatures, day and night, for a given month. If you think about your own experience and ask whether or not the model is simulating temperatures similar to what you would actually feel in summer and winter, you'd find that it's quite accurate. Ocean temperatures change throughout the year as well, but at a different rate and amount than temperatures over land areas. Over land, temperatures vary a great deal between warmest and coolest times of the year, whereas temperatures over oceans are much more moderated and change more slowly. At very high latitudes, in the Arctic for example, the change in temperature is much more extreme, with many areas descending well below -30 during the coldest times of the year. Models are used to understand the causes of past climate change and to project future climate change. Since the causes of observed changes are not always readily apparent, climatologists use a process called attribution to determine the likely causes of observed climate change. In this process, they first use their climate models to estimate how outside influences such as greenhouse gas increases since the Industrial Revolution should have caused the climate to change. They then use statistical tools to look for those expected patterns of change in climate observations gathered over the past 50 to 100 years or longer. These expected patterns, which are distinct from natural internal patterns of variability, are called fingerprints. Attribution, then, is the combined result of detecting the fingerprint of an outside influence in observations, and then carefully demonstrating that other possible causes of observed changes provide less convincing explanations. So what kinds of outside influences on the climate system are we thinking about? Greenhouse gases, aerosols, solar output, and changes in volcanic activity.
So basically, to summarize that part of the video, it was basically enumerating and showing the interaction of what he called forcing agents, which are really external influences on the climate. So things like greenhouse gases that we've talked about before, like carbon dioxide, methane, and so on. That's one external influence for sure. Maybe the most important one. Then there are aerosols, which are like fine particulate matter in the atmosphere, which can affect
help to trap the electromagnetic radiation or the heat,
And then solar output, which is from the sun.
Absolutely,
output from the sun which is very important, as we know, the matter of heating. And lastly, volcanic activity, which we haven't talked much about, but that's also quite important.
I just said that they were significant during the time of the dinosaurs.
Exactly, so that could account for some of the warming then, because volcanic activity is said to have been more higher then than it is now.
And I think they're saying that the observed temperatures actually have been 3/4 of a degree. That's a degree Celsius.
I imagine.
Since the beginning of the 20th century. So
higher.
Higher,
Increased.
Yes.
3/4 of a degree. 0.75 degrees Celsius.
Of the 20th century.
That might not sound like a lot to a lot of people. But it may be important over the long term.
It may be. And the other thing about it is that, as we would see, carbon dioxide, unlike, say, water vapor, which is one of the greenhouse gases, water vapor doesn't stay in the atmosphere long. It can quickly be removed by rain. But carbon dioxide can stay for hundreds, even thousands of years.
Which means, though, that the carbon dioxide you're measuring today It may not be carbon dioxide produced in the last 5 years or 2 years or
but
so you can't make that assumption.
No,
right?
but they say the levels have been increasing since the 1800s. So
right. But I mean, some of what we have today would have been there before.
Absolutely.
It's an accumulative effect rather than a recent effect alone.
And
that's the point I'm making. It's accumulative because it doesn't disappear easily. So it's cumulative.
So the last bit we're going to show you about these models, because models are extremely important. They are what are used to predict what is going to happen, and to the extent that they do not accurately do so, to that extent we are making decisions which may have profound effects without adequate data. So the other thing, the video is going to show us how they actually fine-tune their predictions for areas.
Well, the last part is going to be like a practical application of what he has been saying about modeling.
Yeah.
Because what he's going to be showing in the last part, using continents. You can use continents, regions, or countries.
That's right.
But the best effects will be seen by using a continent.
Yeah.
Okay? Because the changes are less drastic at a continental level. So he's using a continent to show you, okay, this is what the observed temperature changes have been over, let us say, the last 50 years or whatever, on continents, on each continent.
Yeah.
Then he's going to show this is what it's modeled to be. Using the computer models.
That's right.
This is what it was modeled to be.
Yeah.
And he's going to show how does the observed temperature match with what it was modeled, to have been.
Yeah.
So he's showing the correlation between the modeled temperature and the observed temperature and what goes into that.
Okay, so let's take a look at that. Might be a little complex, but listen carefully.
Well, not really. But
Now a look at how climate models can reproduce observed changes at the global, continental, and regional levels. The black line on both of these charts indicates observed global mean surface temperature variations. We can see that observed temperatures have risen approximately 3/4 of a degree since the beginning of the 20th century. The two colored lines, orange on the upper chart and blue on the bottom, show the results from two different groups of models running multiple climate change simulations. Both included the influences of solar and volcanic activity. However, the models represented by the orange line also included human influences, such as greenhouse gases and aerosols in their calculations, and as a result, reproduced the observed changes in global mean temperature quite well. You can see that without including human influences, the models represented by the blue line could not reproduce results similar to global observations during the second half of the 20th century. These external factors, including human-induced ones such as greenhouse gases and aerosols, and natural ones like solar and volcanic, are often called forcing agents because they alter the flows of energy into and out of climate systems. The forcing is said to be external because it originates from events such as a change in the brightness of the sun that occur outside the climate system. Now let's look at what happens at a continental level. The black line in the diagram of North America indicates observed decade-by-decade changes in continental mean temperatures. Notice the 1930s, the Dust Bowl and Depression era, which was warm. The last part of the 20th century was also very warm. The blue band shows the range of average temperature changes simulated by climate models, taking into account only natural forcing agents. The pink band shows the simulated temperature changes that include both natural and human forcing agents. For North America and every other continent, we can see that the decade-by-decade changes in observed temperatures fall within the pink band throughout the 20th century, but that they rise above the blue band in the last few decades. This indicates again that simulations which include human influences provide a better explanation for observed changes than those which don't. Therefore, we can conclude that observed changes in the climate system on a continental level cannot be reproduced without including human influences.
So we've looked at models for predicting climate change. However, there's been a phenomenon that has occurred for at least the last 50 years of persons in significant positions predicting various things, apocalyptic things to happen because of climate change. And the fact is they have not happened. The question is why? So we will be showing you, and please look at the screen as you listen to our voice, something from the New York Post. and I think this was written in November
2021.
21. And the name of this article, which is by the Post editorial board, it's the editorial opinion of the New York Post. They call this 50 years of predictions that the climate apocalypse is nigh. And of course, they're not really very impressed. 50, so the next slide, it says 50 years of prediction that climate apocalypse is nigh.
And it shows a picture of the earth
on
just
fire,
going up in flames.
on fire, the earth burning up.
Devastation, yes, from the heat.
And the next slide, which is the third slide, would be 1972. What does it say?
That's 50 years ago.
50.
1972, there's a UN Environment Protection boss.
He warns.
His name. He warned that we have 10 years to stop the catastrophe.
That means that if we, in 1982, if we didn't do something, there would be catastrophe.
Right. So 1972, it was said by the UN Environment Protection
So that's a significant
boss,
person, the UN
Environment Protection Czar.
Oh,
He's like the Czar of the environment.
Yeah, UN Czar.
He said 10 years we have, only 10, to
Yeah.
stop the catastrophe. That was 72.
So in 1982, which is 10 years later,
We'll go to the next slide.
which is the next slide.
In 1982 now, we have Mr. Tolba, who was the head of the UN Environmental Program then in 1982. And Mr. Tolba,
He's writing, this was written in the New York Times.
New York Times, he said in 1982, he said, if the nations of the world continue their current policies, then by the year 2000, right? We will face an environmental catastrophe as irreversible as a nuclear holocaust.
Well,
that's pretty dramatic.
That's an environmental catastrophe as irreversible as any
nuclear
holocaust by the year
2000, unless things are fixed.
What year are we in?
2022.
So this is 22 years later.
Right.
So some of the other these statements tend to make a mockery of the whole thing.
Catastrophe will witness devastation as complete and irreversible as any nuclear holocaust. This is what Mr. Tolba said
in 1982.
In 1982.
Predicting in 2000. Next slide.
So next slide goes to 7 years later now, after Mr. Tolba said that. And in this case, it was in 1989.
Yeah.
So 7 years into the catastrophe that Mr. Tolba talked about, 7 years later,
it still hadn't occurred.
Still had not occurred.
1989.
So in 1989,
another
UN senior environmental
official tells the Associated Press
that we have
published
to fix
around the
this.
world.
Yes.
Yeah,
we have to fix climate change by 1999, 10 years again, or it will be beyond human control. There will be global disaster. Nations will be wiped off the face of the earth. And there will be crop failures. So this sounds pretty dramatic.
Pretty dramatic.
Nations wiped off the face of the earth by 1999, unless we fix climate change.
Obviously, the New York Post is ridiculing these people. He says, Tolba was back in 1990 to say that we shall win or lose the climate struggle in the first years of the 1990s.
Yes.
So Mustafa Tolba, head of UN Environment Program, we must to fix climate change before 1995.
Yeah. So
And of course,
this is the same Tolba who in 1982 had said we must do it by 2000. So now in the 1990s he said we must do it by 1995, or that's it. We have to win or lose it in the early part of the 1990s.
So in the next slide, we have another set of predictions again.
Because the 90s passed
without the arrival of the end times.
Of the climate end times.
So unless you consider Vanilla Ice Cream. I think he was a singer.
Vanilla Ice.
So they are ridiculing these predictions. Vanilla Ice, I think, was a rapper, a white rapper. But that only turned up the volume. In 2004, the Guardian newspaper said a secret report from the Pentagon to President George W. Bush said climate change would destroy us. Yes. And it says, now the Pentagon tells Bush, climate change will destroy us. And this was a secret report.
And what were the elements of that destruction? The rioting.
And that, by the way, was by Mark Townsend and Paul Harris in New York.
21st of February 2004.
So next slide.
No, I should talk about the elements of the destruction.
Yeah, it's on the next slide. Okay. The elements is on the next slide, which says, among the predictions, you want to read something?
Among the predictions that were made, this is in 2004, predictions made were that one, major European cities will be sunk below rising seas.
Wow.
Major European, I guess that's like Berlin, London, Paris, and so on. Yes, will be sunk below rising seas. Okay. Second prediction: Britain will be plunged into a Siberian climate. You know what Siberia? Our listeners should know that Siberia is just a very, very, very cold place. Okay?
There'll be nuclear conflict.
So by 2020, which is 2 years ago, Britain should have been plunged into a Siberian climate. There'll be nuclear conflict, mega droughts, famine, widespread rioting across the world.
The Guardian described this as humiliating to the Bush administration because they weren't doing enough to tackle climate change. No word on whether the Pentagon or the Guardian were humiliated now that it's 2021 and Britain is still having experiencing summer. So
it's a very sarcastic
argument. That there's a disconnect between some of the scientific models, unless the scientific models are predicting this, we don't know. But then another prediction came and went in the meantime.
Yeah.
In 2007, Rajendra Pachauri, head of the
UN climate panel.
The UN keeps coming up, The UN climate panel said, if there is no action before 2012,
it's too late.
That's too late. No, we are
10 years after 2012 now. And he said by 2012, if you haven't taken action, it will be too late.
And he said,
what we do, this is what he said then. And he said this in 2007.
Yeah.
He said, what we do in the next 2 or 3 years will determine our future.
Yeah. If there's no action before 2012, that's too late.
That's too late, yes.
And the New York Post said that year did bring disaster in the form of the movie 2012.
Yes.
So they're laughing at them. Right. But besides John Cossack's career, the rest of us survived.
Right. So moving on quickly, they say that the goalposts have moved again because in 2019, the UN said 11 years are left to prevent irreversible damage from climate change.
Yeah.
Okay, 11 years are left.
Yeah.
Only 11 years are left to prevent irreversible damage from climate change. And the last slide said, until 2030, or 58 years. So that gives us until 2030.
Yeah.
The UN declaration in 2019. That's 11 years, right?
Yeah.
Gives us until 2030. Or 58 years after the warnings of 1972. Advocates scream louder or they write more like the book of Revelations. Yeah. There's a upheaval of modern life. They want us to agree to that. They want us to spend trillions. But after all that alarmism, they cried like decades of alarmism.
They
sound like Chicken Little.
Like the boy who was warning people. This is the boy who cried wolf.
Wolf, yeah.
Boy who cried wolf.
They said boy who cried warming.
Yeah.
And people have tuned them out. So climate change is real. Adapting to it, mitigating with technology is a realistic solution. But they say what they don't want is this kind of alarmism. Okay?
So the question is, climate change, or there is something happening, but the approach is wrong. This is what the Washington Post is saying. They are ridiculous.
So as we wrap up today and we are going out, we want to leave you with a video from PragerU, which is done by a man called Mr. Coonan.
Yeah.
And he was the Undersecretary for Science in the Obama administration. Yeah. So let's see what Mr. Coonan says. He's saying, is there really a climate change emergency?
Yep. Let me just say, PragerU is Prager University. It's an online university put on by conservatives. Right. It is a conservative political opinion, yes. Right. And it's interesting that someone from the Obama administration, who is by definition liberal, has this to say.
Is there really a climate change emergency? We are leaving you with this question today as we leave the Issachar Hour. Yeah. We want to say thank you for joining us. We'll pick up right here in the next show to talk about the climate change emergency and to look at a more balanced view on it, to try to keep a cool head in the matter of climate change. So we are going out to leaving you with PragerU. Is there really a climate emergency? Thank you for being with us today on the Issachar Hour.
Hubris is a Greek word that means dangerously overconfident. Based on my research, hubris fairly describes our current response to the issue of climate change. Here's what many people believe. 1. The planet is warming catastrophically because of certain human behaviors. 2. Thanks to powerful computers, we can project what the climate will be like 20, 40, or even 100 years from now. And 3. That if we eliminate just one behavior, the burning of fossil fuels, we can prevent the climate from changing for as long as we like. Each of these presumptions, together the basis of our hubris regarding the changing climate, is either untrue or so far off the mark as to be useless. Yes, it's true that the globe is warming, and that humans are exerting a warming influence upon it. But beyond that, to paraphrase a line from the classic movie The Princess Bride, I do not think the science says what you think it says. For example, government reports state clearly that heat waves in the U.S. are now no more common than they were in 1900. Hurricane activity is no different than it was a century ago. Floods have not increased across the globe over more than 70 years. Greenland's ice sheet isn't shrinking any more rapidly today than it was 80 years ago. Why aren't these reassuring facts better known? Because the public gets its climate information almost exclusively from the media. And from a media perspective, fear sells. Things aren't that bad doesn't sell. Very few people, and that includes journalists who report on climate news, read the actual science. I have. And what the data, the hard science, from the U.S. government and the UN climate reports say is that things aren't that bad. Nor does the public understand the questionable basis of all catastrophic climate change projections, computer modeling. Projecting future climate is excruciatingly difficult. Yes, there are human influences, but the climate is complex. Anyone who says that climate models are just physics either doesn't understand them or is being deliberately misleading. I should know. I wrote one of the first textbooks on computer modeling. While modelers base their assumptions upon both fundamental physical laws and observations of the climate, there's still considerable judgment involved. And since different modelers will make different assumptions, results vary widely among different models. Let's just take one simple but significant assumption modelers must make: the impact of clouds on the climate. Natural fluctuations in the height and coverage of clouds have at least as much of an impact on the flows of sunlight and heat as do human influences. But how can we possibly know global cloud coverage, say, 10, let alone 50 years from now? Obviously, we can't. But to create a climate model, we have to make assumptions. That's a pretty shaky foundation on which to transform the world's economy. And by the way, creating more accurate models isn't getting any easier. In fact, the more we learn about the climate system, the more we realize how complex it is. Rather than admit this complexity, the media, the politicians, and a good portion of the climate science community attribute every terrible storm, every flood, every major fire to climate change. Yes, we've always had these weather events in the past, the narrative goes, but somehow climate change is making everything worse. Even if that were true, isn't the relevant question, how much worse? Not to mention that worse is not exactly a scientific term. And how would we make it better? For the alarmists, that's easy. We get rid of fossil fuels. Not only is this impractical, we get over 80% of the world's energy from fossil fuels. It's not scientifically possible. That's because CO2 doesn't disappear from the atmosphere in a few days like, say, smog. It hangs around for a really long time. About 60% of any CO2 that we emit today will remain in the atmosphere 20 years from now. Between 30 and 55% will still be there after a century, and between 15 and 30% will remain after 1,000 years. In other words, it takes centuries for the excess carbon dioxide to vanish from the atmosphere. And so any partial reduction in carbon dioxide emissions would only slow the increase in human influences, not prevent it, let alone reverse it. CO2 is not a knob that we can just turn down to fix everything. We don't have that ability. To think that we do is, well, hubris. Hubris leads to bad decisions. A little humility and a little knowledge would lead to better ones.